One of the most interesting medical phenomenons that I've come across in my research is something called P-Glycoprotein, or permeability glycoprotein. And I wanted to make a quick video today. This is such a crucial factor, and I don't know why these three letters aren't on everybody's lips. So what's interesting is the knowledge about this first came from cancer research, but they made a bunch of miscalculations along the way. So when they tried to apply what they learned, they found it didn't really improve the outcomes because they wrongly assumed that it was just the cancer cells using P-glycoprotein to be resistant to certain drugs, such as chemotherapy. But in reality, this is a crucial protein for many of our normal somatic cells, our normal body cells. So I wanted to start with these two studies, P-glycoprotein in cancer. What do we currently know? If we scroll down to section 2, the first ABC transporter, so it says the first ABC transporter described was the permeability glycoprotein, also known as P-glycoprotein or just PGP, also known as ABC-B1. This was discovered in 1976 by Giuliano and Ling. So they found this glycoprotein, which prevents certain substances accumulating within cells. And the way it works is it actively outputs these substances from the cells. It's found in some very key places: the capillaries of the brain, the blood-brain barrier, the liver, the gastrointestinal tract, the kidneys, the testicles, the ovaries, adrenal and pituitary glands, placenta, etc., etc. So they have this chart right here with all these different PGP expression sites. In addition to the ones we've mentioned, basal ganglia, cerebral cortex, the colon, fallopian tubes, the gallbladder, hippocampus, the kidney, the liver, pancreas. So there's a number of drugs that are dealt with by PGP, and they're called substrates of PGP. So a PGP substrate is a drug that these PGP pumps pump out of our bodies. So PGP substrates are drugs or toxins that our body pumps out of our cells using PGP, making it one of the key detox pathways in our body. So why do we never hear anybody talk about this, either from the mainstream poison cult or the alternative poison cult? Where are the rational voices talking about how to detox? So it says, despite successful attempts of MDR reversal in cell culture settings, the shortcoming in the clinical setting is associated with low specificity and high toxicity levels. The toxicity can be interpreted as a result of the dosage required for PGP inhibition that leads to unacceptable side effects due to non-selective distribution in the body upon delivery, as well as the co-administration with anti-cancer drugs, which may be noxious. So let's look at one of the many drugs that it protects us from, morphine. So let's look at this paper called Effects of a Potent and Specific P-Glycoprotein Inhibitor on the Blood-Brain Barrier, Distribution, and Anti-Nociceptive Effect of Morphine in the Rat. So anti-nociceptive effect basically is just pain-killing effect. And they measure it based on how slowly the rat, or how little the rat, reacts to painful stimuli in the tail, which is arguably not a good thing. You know, there's a time and a place, sure, for painkillers, but there's also a time and a place for pain. Pain allows us to prevent further damage, allowing the rat to move its tail so it doesn't get burned, etc., etc. So here's a quote from the paper. So they looked at the concentration of morphine in the brain, with and without this PGP inhibitor called GF-120-918. So let's look at this summary table here. The area under the curve for concentration is an important measure because it tells us over time how much total concentration there is. So you can see it goes from 22.7 in the control group. This is talking about morphine concentration over time. So the control group had 22.7 area under the curve, micromole minutes. But when they inhibited the PGP, it went up to 32.3. That is an extremely drastic jump. And we can see the same thing in study after study after study, with different PGP inhibitors and different PGP substrates. So a PGP inhibitor such as GF-120-918 prevents the detox pathway called PGP from working properly. So the cells get more saturated with the poisonous substances. And then, of course, if you have more morphine, you're going to have more pain-killing effect. And that's what this chart here shows. So the triangles are the control arm, and the circles are the PGP inhibited arm. And you can see this massive difference in the antinociceptive effect. And you can see in this chart, this is especially profound in the brain because of how much PGP protection the brain has, because of the PGP at the blood-brain barrier. So at 30 minutes in, the control group had 20.4 nanomoles in the brain, whereas the PGP inhibited group had 35.6. So that's a huge jump. But an even larger jump, 1 hour in, 24 in the control group in the brain, and 71 in the brain of the PGP inhibited animals. At 180 minutes in, 7.6 in the brain of the control, and 19.8 in the PGP inhibited group. So we're talking drastic differences in how much accumulation, how much absorption of toxic drugs that are PGP substrates when P-Glycoprotein is inhibited. So how can anybody dose their patient correctly? How can any doctor prescribe PGP substrates that are toxic without first checking if the person has genetic deficiencies and or are chemically inhibiting their PGP? And why is nobody talking about this? I find it outrageous. So what various researchers found in their Petri dish experimentation is that when they inhibited this PGP in the cancer cells, and then they administered their toxic drugs, the cells were more inclined to die because they would uptake instead of expel these toxins. So they declared victory and started dosing their cancer patients up with PGP inhibitors. But they did not find clinical success. So in this paper here called Inhibition of the Multi-Drug Resistance P-Glycoprotein, Time for a Change of Strategy? By Callaghan, Luck, and Babawi, they write, despite considerable in vitro success, so in glass experimentation, there are no compounds currently available to block PGP-mediated resistance in the clinic. The failure may be attributed to toxicity, adverse drug interaction, and numerous pharmacokinetic issues. And with hindsight, it's obvious why. And look at what the next sentence says. This review provides a description of several alternative approaches. These include drugs that specifically target resistant cells. So basically they're saying, we need to find a way to specifically target the cancer cells and not all these other PGP protections in the body, especially because we're going to be dosing people with toxic PGP substrates. This paragraph is very telling. Originally, it was thought that the actions of PGP were limited to conferring resistance to classic genotoxic anti-cancer drugs. The broad or polyspecificity of PGP is legendary, and the list of compounds known to interact with this transporter is well in excess of 300. The actions of PGP are in no way limited to these drugs they were trying to poison the cancer cells with. So their first attempt was to use verapamil. But, as it says here, clinical trials with verapamil were beset by serious cardiac side effects, and the compound was removed as a viable option. So it was causing serious cardiac side effects, probably because it was inhibiting the protections, the bodily defenses. And I'm just bringing this up because this is cancer researchers running into a wall, bumping their heads against a wall, thinking they found the secret. But really, they just found how the body detoxes itself from many toxins. This is extremely important because of all the PGP inhibitors that many people are taking. Hot peppers, quercetin, K2, etc., etc. CBD, THC, vitamin A. But somehow they still can't figure out what's going wrong. The third generation, so they kept trying this, the third generation of PGP modulators was frequently associated with adverse drug reactions that necessitated a reduction in the dose of anti-cancer agents. There's this other key protein that's often tied in. We're not going to talk about it too much today, but it's CYP3A4. And so when you see people peddling grapefruit juice, be very wary, because that decimates CYP3A4, which will also lead to an accumulation of many toxins that people may be exposed to, and many toxic drugs. The combined effects of these two defender proteins will influence the absorption, distribution, metabolism, and elimination of a large proportion of known medications. Therefore, the co-administration of two drugs, the inhibitor, aka modulator, and the anti-cancer drug that interact with both PGP and CYP3A4 often generates unpredictable toxicity related to the emergence of unwanted pharmacokinetic parameters. Such issues with pharmacokinetical profiles have resulted in the apparent downfall of potent PGP inhibitors. They mention here Taricodar as fitting in this category. The authors say, the fall from grace of this leading PGP inhibitor led to considerable pessimism regarding the validity of utilizing efflux pump inhibition as a means to overcome drug resistance. So this is very interesting and noteworthy in the context of cancer research, but I'm just bringing this up as a history lesson to show how PGP was stumbled upon and how we learned over time that it's actually a crucial bodily defense mechanism. It's a detox pathway. So if we go to the Wikipedia page, for instance, it's an important protein of the cell membrane that pumps many foreign substances out of the cells. It has broad substrate specificity, which means there's a lot of things it pumps out. It likely evolved as a defense mechanism against harmful substances. PGP is extensively distributed and expressed in the intestinal epithelium, where it pumps xenobiotics such as toxins or drugs back into the intestinal lumen, in liver cells where it pumps them into the bile ducts, in the cells of the proximal tubule of the kidney, where it pumps them into the urinary filtrate, and in the capillary endothelial cells, comprising the blood-brain barrier, and the blood-testes barrier, where it pumps them back into the capillaries. So why are people pushing all of these toxic PGP inhibitors, over-the-counter PGP inhibitors? I think it's really, really insidious. I think it's part of binary weapon poisoning operations, psychological operations to get people to poison themselves with binary weapons. And what's interesting is if you look up some of the major drugs that people are taking, such as these mRNA injections that use polyethylene glycol as a delivery mechanism, or ivermectin, or another example would be remdesivir. Isn't it interesting that all of these are PGP substrates, meaning people will get more absorption, more exposure, more toxicity if they're on PGP inhibitors or if they're genetically deficient in PGP. And then you look around and you see all these potent PGP inhibitors being pushed, such as K2 and quercetin, and look at who they're pushing those two on. And it all becomes so clear what's going on. It's 2+2 level addition, guys. This is an extremely interesting study that I found. Lethal quercetin-digoxin interaction in pigs. So quercetin is a potent PGP inhibitor, and digoxin is a toxic PGP substrate. 67% of the pigs in this study, quote, died suddenly through the combination of these two drugs. And it shocked the researchers. The paper was called Lethal Quercetin-Digoxin Interaction in Pigs by Wang et al. Quote, the concentration of 40 milligrams per kilogram quercetin significantly elevated the concentration maximum of digoxin by 413% and increased the area under the curve concentration by 170%. The results indicated that a very serious pharmacokinetic interaction occurred between quercetin and digoxin. The concomitant administration of digoxin and quercetin, or quercetin-containing herbs and dietary supplement, should be avoided. Unexpectedly, within 30 minutes after drug administration, 2 of the 3 pigs receiving combined therapy died suddenly, and the third pig suffered from typical mild symptoms of acute digoxin intoxication. In summary, quercetin significantly enhanced the absorption of digoxin in pigs, possibly through the inhibition of intestinal PGP. Such interaction would cause serious adverse drug reaction clinically if quercetin and digoxin were concomitantly administered. It is suggested that concurrent use of quercetin or quercetin glycoside containing herbs or dietary supplements with digoxin or other PGP substrates should be avoided Otherwise, close monitoring of the critical therapeutic drugs is required. And it's also important to note that there's many genetic variables at play too, which dictate how much PGP protection people have. For example, African populations, on average, have much more PGP protection due to a higher concentration of dominant alleles in the C3435T polymorphism, which has to do with the MDR1 gene. MDR1 is a related concept. It stands for multi-drug resistance. And that term was initially coined because they were realizing these cancer cells were resistant to their toxic cancer drugs. Little did they know that many of our cells in our body use this defense mechanism to be resistant not just to drugs, but also to toxins, poisons. On the other hand, in contrast to African populations, white Europeans and Southwest Asians have much worse genetic predisposition for toxic PGP substrate poisoning due to the larger concentration of recessive alleles, resulting in C/T and T/T genotypes for the MDR1 gene exon 26, C3435T. And I found this study called the C3435T mutation in the human MDR1 gene is associated with the altered efflux of the P-Glycoprotein substrate, rhodamine 123, from CD56 plus natural killer cells by Hitzel et al. Quote, carriers homozygous for this polymorphism, TT, showed more than twofold lower PGP expression compared to the CC group. So it's not just drugs inhibiting PGP, it's also genetic differences in how much PGP protection there is in the first place. There's a really sad example of a boy who was put into a coma. A 13-year-old boy sent to the hospital in a coma after one ivermectin pill. Quote, his condition worsened 6 hours after he received ivermectin with persistent neurologic signs, including coma, ataxia, which means loss of coordination, pyramidal signs, and binocular diplopia, as well as abdominal pain and vomiting. And they think the issue was, after sequencing the genetics, the ABC B1 sequencing identified the child as a compound heterozygote for two nonsense mutations, which would result in a failure of brain protection and probably would have induced high exposure of the central nervous system to ivermectin and the toxic effects observed. So why are they not doing genetic testing? Why are they not testing how much PGP protection people have? Why are they not asking, are you inhibiting your PGP? I think it's because they're doing it on purpose, and I say that because I watch what these evil bastards push. They push K2, they push quercetin, they push grapefruit juice, they push cannabinoids, they push coffee enemas. I mean, how obvious can it get, folks? So if you go to Drug Bank online, there's a huge list of P-Glycoprotein substrates. So these are the drugs that if you're on K2, or if you're on CBD or THC, or quercetin or K2, the list goes on and on and on. All these PGP inhibitors that people are taking. If you're taking one of those, or multiple of those, and you get exposed to a toxic P-Glycoprotein substrate, you're increasing the exposure. You're increasing the toxicity. Look at all these drugs that PGP protects us from. 395 just in this table. There's ivermectin, very toxic PGP substrate. It's also a very potent PGP inhibitor, so opening the door to lots more toxicity from other directions. Also, very interestingly, PEG, the delivery vehicle for these mRNA shots, is also a PGP substrate. PEGs are taken up by the cells and act as PGP substrates. So why are the people who are taking these shots not being informed that they're going to have increased absorption, increased dosing, if they're genetically deficient in P-glycoprotein or if they are chemically inhibiting it? This paper is called Impact of Molecular Weight on the Mechanism of Cellular Uptake of Polyethylene Glycols, with particular reference to P-glycoprotein. Look at this drug. Remdesivir is a substrate of P-glycoprotein. So another one where if you're taking a PGP inhibitor, you're prone to higher exposures of these types of drugs called PGP substrates. I'm trying to make this very plain, very easy to understand. But let's turn back to this paper, Inhibition of the Multi-Drug Resistance P-Glycoprotein, Time for a Change of Strategy? Let's look at this quote here. The presence of endogenous or physiological PGP has also become problematic to the chemical inhibition strategy. PGP is expressed at barrier tissues to sanctuary sites, for example, the blood-brain barrier, and at secretory and absorptive tissues, for example, the gastrointestinal tract. This protein acts as a cellular defender and is involved in establishing the overall pharmacokinetic profile for numerous drugs. Unfortunately, chemical inhibitors are not capable of discriminating between PGP expressed at normal sites in the body and that found in cancerous tissue. Therefore, the strategy generates unwanted side effects at a number of non-tumor sites in the body. For example, increased permeability at the blood-brain barrier. So it's a multiplier effect if people are inhibiting their PGP or if they're genetically deficient in PGP. This is a major variable. This is a major factor. Here's another very concerning study where they shut down PGP with chemical inhibition, and then they gave ivermectin because it's toxic to mosquitoes that come and bite the pigs. So they dosed pigs with ivermectin plus PGP inhibitors. And what happened? Well, one of the pigs died. Pig 72 died and was replaced by pig 75. So pig 72 was in the ivermectin plus the ketoconazole group. So pigs are dying left and right. It's obvious why. And yet the same strategies are being purposefully pushed on conservatives and truth seekers. And also the ramifications for people who take these mRNA shots are massive if they're inhibiting their PGP. What's also interesting about this study is they measured the concentration over time. So here's a chart that shows you the concentration of ivermectin over time. And you can see when they use the ketoconazole plus the ivermectin, the peak is much higher and the area under the curve is much larger. And this is a pattern that we see time and time again. Study after study after study showing us that inhibiting the PGP, and then you take a PGP substrate, there's more accumulation, more absorption, longer exposure, higher peaks of the toxic PGP substrate. I feel like Winston Smith trying to teach people what 2 + 2 equals. So isn't it interesting that all these PGP inhibitors are being pushed on populations that are being exposed to toxic PGP substrates in mass? Almost like they're trying to kill us. Or in the case of the anti-fertility drugs that are PGP substrates, sterilize us. Or both. So let me know what you think, and I hope you have a great rest of your day.